Everyone. I'm Lindsay Lewis, editor of Building Enclosure. Thanks for listening along with us today. On May 13th at 2 p.m. Eastern Time, we have a free webinar, Unlock Enhanced Building Performance, Improve Durability and Efficiency Using Air Barriers and Vapor Retarders. Our presenters, Andrea Wagner-Watts, Building Science Education Manager for GAF CPLAS Building and Roofing Science Team, and Benjamin Meyer, Building Enclosure Business Director with CPLAS, are here with us today to talk about what to expect during the presentation. Andy and Ben, thanks for sitting with us.
Certainly.
Thanks for having us.
So to get started, what are some main differences between air barriers and vapor retarders, and how do you know when to use which?
If this was a simple answer, Ben and I wouldn't have to do this presentation anymore. To start with air barriers are designed to restrict the movement of air through something. It could be a balloon, it could be a building enclosure. An air barrier can also be a vapor retarder, or it usually is a vapor retarder to some extent. A vapor retarder is designed to restrict or slow the movement of moisture vapor through a building enclosure, or again, a balloon is a great example. And how much it restricts that movement of moisture will depend on how much of a vapor retarder that material is. How do you know when to use which? The building science answer of it depends. It depends on the conditions of the space. It depends on if it's a roof. It depends on the wall. It depends on everything else that's going into that building enclosure. And that is what we're diving into deep into this presentation, is to help you know what questions to ask to come to that conclusion.
Now, how about looking at the building codes side of things? What code requirements are there regarding these systems?
So I'll take the lead on that question, because again, if it were easy, that would be not a problem. But one of the challenges with codes is they're always changing, right? And so we've recently kind of gone through an adoption cycle where all the codes are really moving forward and adopting almost the most current one, but most folks end up in the 2021 IECC. And that also includes, more regions that are taking on the requirements of air barriers, like California has air barrier requirements in their Title 24. So just recently, it's becoming more and more relevant. And that's kind of like just big picture. Now, from a code perspective around air barriers, they've also gotten a little bit more refined. So not just specifying materials, which has been what's been included for a fairly long time, probably more than 15 years, for most areas that are practicing air barrier requirements, but really extending to the application that really the goal of air tightness is that the whole building is actually airtight, that you didn't just specify materials, that all the things are connected. And that requires whole building air tightness testing and really quality assurance to make sure that they've actually been connected. And so those things in the most current versions are much more required in terms of their performance, not just specifying.
Now, speaking of different climate zones, what do you need to think about when you design roof assemblies in different climate zones?
We look at a number of things. We look at temperature extremes. We look at how much how long we are expected to be at different temperatures. Is it a more heating dominated climate where it's hotter inside the building than it is outside? Or is it a cooling dominated climate where we try to keep our buildings cooler on the inside than they are on the outside? Because that is going to determine how moisture is going to want to move through that assembly. And so we look at how these assemblies are performing hygrothermically, how moisture and heat are trying to move through, and then that will help us determine if and where we should place a vapor retarder in that assembly to stop the movement of moisture at a point where it can't cause problems within our assemblies. So again, it's a very complicated subject, but we hope to use this webinar as a starting point, as an intro, so you can come away with knowing a bit more about what you don't know, and you can pull in the right folks and ask the right questions to get to the right answer.
Now, I noticed on the webinar description that you'll be talking about compliance a little bit. So my question is, when it comes to achieving compliance, what are some of the biggest hurdles?
Yeah, we talked a little bit about, fundamentally the biggest hurdle is that there's change in code. So that compliance, even knowing that you're out of compliance in the first place, is kind of the first awareness to have. The second is really, all right, there's a new set of requirements. How do we implement? How do we make sure that we're doing the right thing? And so that really, especially as you move from material specifications to whole building requirements, is what are you doing in the first place on the design and the quality control and in the pre-construction to make sure you get where you need to go after the building is built? It's kind of, beginning with the end in mind is super important when it comes to airtightness, that you have all those pieces in place, you have all the contractors on board, so you get where you want to go.
Now, will you be going over any case studies?
The answer to this question in our presentations is always yes. We learn from how others do it, especially within the design community. It's much easier to look at a building that has very specific requirements and understand how they came to their conclusions than it is to talk about this in the abstract. So we'll, of course, be including at least one or two. Maybe we'll throw in a couple bonus ones as well.
Yeah, and everybody loves a good cautionary tale. Somebody that did it, worse than they did. So that at least gives you, an idea what to look out for, whether it's, moisture in the building or, issues that they could have prevented if they just had a little more conversation up front.
Well, lastly, I want to ask, what else will attendees learn during the lab webinar?
I think the big takeaways from this presentation is understanding the answers to the question we started with. What are the main differences between an air barrier and a vapor retarder? How do we call things by the proper names so that they get installed in the proper way and that they ultimately perform at the end in the final project? We want people to be prepared for this new test that's coming at the end of the class when the building's built and they have to do a whole building airtightness test, that it's not a big stressful moment, but everyone feels prepared because it was started right from the start.
Yeah, I would add, communication and coordination is the key. And that's what should be the big takeaway, that hopefully you don't come to this hour expecting that you're going to come out as an expert, but you come out knowing who to call, who to talk to, who you should ask these questions. So that everybody gets on the same page, because that's more important than even having the right answer, is everybody's on the same page of what the answer is going to be.
Well, thank you again, Andy and Ben, for your time today.
Thank you very much.
Appreciate it.
To register for this free webinar, head to continueducation.bnpmedia.com. Until next time, visit us on buildingenclosureonline.com for your educational and technical resources.